Yes, class. Am I audible now? The screen is sharing. One thing I wanted to discuss, Mariam, Noha, Leena, and Khadija. We had missed one class on Tuesday. So, when are you people available for a class? Not this Friday, next Friday, any day if you are available, just let me know. When do you want to have the class? Because we have to complete quickly the fluids lesson. Thermal, for some lessons of just let me know. Just type in the chat column all of you so I can see when all of you are available. Not tomorrow, not tomorrow. Tomorrow I won't take. Apart from tomorrow, whenever you think you are available. So holiday for you. In the morning if you want to have a class. Or on Monday are you available in the evening or on Wednesday? Just let me know. Okay, Khadija is available any day. Otherwise on Wednesday, I'll schedule your class. Because then we'll have 3 consecutive days, no? Tuesday, Wednesday, Thursday. So on Wednesday, oh no, Wednesday, Lena has her some class, maths class. Wednesday. Monday, on Monday, it's fine by all of you. One class only, I just want to take. Okay, before the bio class, then I'll sit. From 6, you have the bio class. So 6 p.m. 6 p.m. IST you're saying or 6 p.m. your KSA timings? 6 p.m. KSA. Okay, then before that I'll have. Okay, before that. Otherwise, then one day, one and a half class only I'll take. I just want to complete this lesson. No, some it will take next week some classes. Okay. We'll complete then from the next week and the next week and the next week. We'll be having extra classes also because we have to quickly complete the syllabus. Okay, now starting with capillarity. Before that capillarity, you have a concept known as angle of contact. So angle of contact is basically the angle that is formed between the liquid and the solid surface. Like if this is the liquid which is present and this is the container, so there is the angle that has been formed. But see, this is also one angle, this is also one angle. So we always take this inside angle which is formed. This is known as angle of contact. This was a concave meniscus, so this is the angle of contact. It's less. From here, drop a tangent to the surface of the liquid. Now take it from the inside of the container. This is angle of contact for the convex. And for plane, see, drop a tangent, this inside angle. This is 90 degrees. This is how we take. This angle that we are getting, this is the angle of contact. This is the angle of contact. So on what factors the angle of contact depends? Nature of the liquid and the solid in contact. Because why nature? Because nature will determine whether it's concave or convex or a plane. Medium that exists above the free surface of liquid. This means this medium. This which is existing above the liquid surface. Impurities present in the liquid, that is the angle of contact. So remember, angle of contact is inversely proportional to impurities. This is inversely proportional to impurities of the liquid. But the angle of contact is directly proportional to temperature. These are a few points, just write it down, then I'll start with the details. Now coming to the details of angle of contact. So if the angle of contact is formed from a concave upwards meniscus. So see here the adhesive forces will be stronger than the cohesive forces. We have discussed about the forces. So liquid will wet. It means it will wet means the cohesive forces are the adhesive forces are stronger. Adhesive force means between the two different substances. So water and the contact. So this will be the angle of contact. So theta is acute. Acute means less than 90 degrees. So best example is water in glass. So liquid will wet the solid, meniscus of the liquid will be concave and liquid will rise in the capillary tube. It will rise, this we'll see later. This won't be clear right now because we have not done capillarity. Now talking about angle of contact is obtuse. Now see, when convex upwards meniscus is made, so cohesive forces are greater than the adhesive forces. So now in this case, liquid will not wet because the molecules made up of safe substances are stronger. So example is mercury in glass. So angle is greater. You can see here in convex meniscus, it's greater. It's more than 90 degrees. So liquid will not wet the solid. Meniscus of the liquid will be convex and liquid will get depressed in the capillary tube. This again, last point I'll explain in capillarity. And if it's plain, then direct 90-degree, adhesive force and cohesive both are equal, the way water is taken in silver container. So these are the details about angle of contact. Whichever case comes, you have to explain everything. Quickly write it down and start with capillarity. Okay, now talking about capillarity. So what is meant by capillarity? You have, suppose I have a container and I have filled this with water. I filled it completely with water. And we have capillary tubes. These are very, very fine tubes, very narrow tubes. The diameter is very small, the diameter of these tubes. And what happens is that without any external force, as soon as you'll put these are thin capillary tubes. So water automatically goes here more than the level of water which was present like this. This is one case, that is the liquid is rising. This is one case in which the liquid is rising. Second case is that this is the container. Suppose I have filled it with mercury. Okay, this time I filled it with mercury. And I have kept a very, let's say, I have kept a very thick, not a thick, let's say thin capillary tube only. Now see, it is observed that the level of mercury within this, this was the container, level of mercury within this here, it will fall. The actual level is still here, the level of mercury will be till here. So level of liquid is falling. So this rise or fall through capillary narrow tube means diameter is very less, is known as capillarity. Capillary tubes are present. So we have a full-fledged derivation for it. Suppose we have taken a container and in this we have kept a capillary. Capillary tubes are very narrow. This I'm not, if I'll show a very narrow tube, then the diagram part you will not be able to understand. Suppose I have taken A point, I have taken B point, and I have taken C point. Random points I have taken. Now look, on introducing capillary tube in liquid, pressure is less than the pressure at the convex side is less than the concave side. See, it means when we have introduced this will form a meniscus. So pressure at the convex side is less than the concave side. Now pressure at point A, this point A is exactly on the surface, so it will be equal to atmospheric pressure. But this P point will be having surface tension as well, excess pressure. So we have PA minus 2S minus R. Remember, we have done excess of pressure 2S minus R. This I told you, this is the formula. And for soap film, we have 4S minus R. So total pressure here at B point, PB when I am talking, this is P naught minus 2S by R. If we take point C outside the capillary tube at the same level of, see, one more point I have taken outside it, but at the same level. So pressure at the C point will be P naught, that is from the atmosphere. We are not including the pressure of the mercury from the water. Now look, due to this pressure difference, fluid will flow from C to B. Correct. Why? Because here we are considering the surface excess pressure. Here, this is just a random point that we have taken and we are not considering. So there will be a pressure difference. So what will happen? There will be pressure actually, there will be a pressure difference. So total pressure will be P naught minus 2S by R plus the pressure exerted by the liquid column H rho G. This we have studied. Now see, when will the pressure stop? When both the pressures are equal. It is equal to the atmospheric pressure. So PB is equal to P naught. Put it P naught, PB, we are putting it as P naught. So P naught minus 2S by R plus H rho G. P naught will get cancelled. H rho G is equal to 2S by R. From here, H will be equal to 2S by rho G R. All right, what are all the details that I have written? H is the height. Height of what? Height to which the water will rise or fall. Rho, this S is the surface tension. Rho is the density. G is the acceleration due to gravity, 9.8 meter per second square. R is the radius. All right, this is the radius, but radius of what? Radius of the seat. We have two radius. One is the radius of this tube. Okay, the radius of the, and one is this radius of the meniscus radius. So this is radius of meniscus, not the tube. This is written here. R is the radius of meniscus. Understood? This is the radius of meniscus. Now see one thing. If I want to write the same formula in terms of the meniscus, let's say. So suppose this one is the radius of the meniscus. Do you get it when I say radius of meniscus? See, this is the tube. Suppose this is the curve. So this curve also must be having a circle, no, to which this curve is a part of. Or if I am saying this one, so this will also be a part of a sphere. This will also be part of a circle. Understood? So that's what is the radius of the meniscus, and the radius of tube means radius of the capillary tube. So if you see, this small r is the radius of tube, capital R is radius of meniscus. So there's a triangle that has been formed. In triangle O1M, cos theta will be equal to base by hypotenuse. So that is R by capital R. So capital R is equal to R by cos theta. So height will be 2s cos theta divided by 2 by r rho g. Small r will now come. See, I have just substituted this value. I have just substituted this value. This is small r rho g. Now what is it? This is the radius of tube. This is radius of tube. Because radius of tube is usually given to us. Look, I am repeating. Just pay attention. We have taken, forget everything. These are just the extra details. From here, pay attention. PB is equal to atmospheric pressure minus the excess pressure plus H rho G, correct? Now, if atmospheric pressure will stop, then only there won't be a pressure difference. So we have equated them. When we have equated, both of these will cancel. So when this will go, it will be positive. So 2S by R is equal to H rho G. Height is equal to H is equal to 2S by rho G R. 2S by rho G R. This is the height of the liquid column. H is the height, S is the surface tension, rho is the density, R is the radius of meniscus. The problem is that radius of meniscus will not be given to us every time. We want the radius of tube. So here I have taken a tube whose radius is small r. So I've just taken their relation through this. This is capital R is equal to small r by cos theta. So height of, now the height's new formula in terms of radius of tube is rho s cos theta by r rho g. I've repeated it once also. Now let me know if you want me to repeat once more anything you have not understood. Yes, class, please update if you have not understood anything. Any doubts? Khadija, clear? Mariam?
Yes, ma'am.
Start writing it down. In between, if you get stuck, you're not able to understand any point, just let me know. From capillarity, write it down. This derivation can come in your exam. This says that a glass U tube with diameter 3 millimeter and 6 millimeter is placed in water beaker as shown. It means, see, this is like, this is one single tube with one 6 centimeter and sorry, 6 millimeter, one with 3 millimeter. So basically you have to find the difference in water level. Means if in one tube, suppose water rises to this level, and in one tube, other one, this rises to this. So this difference you have to find out. So one method is simply take this height, calculate this height, take the difference. It means if I'll put H1, 2 rho, the formula is also written over here, 2 rho cos theta by R, 2s cos theta by R rho G. So 2s surface tension is 0.07. Cos 0 degree is 1, so I'm not writing. 2s by R rho G. Diameter is 3, so radius will be, see, radius will be 1.5 millimeters. So this is 1.5 into 10 to the power minus 3 meters. Density 10 to the power 3. Acceleration due to gravity 10. H2 is 2 into 0.07 by 1. Other diameter will be 3 millimeters. So this will be 3 into 10 to the power minus 3 into 10 to the power 3 into 10. Then you just have to take out H2 minus H1 for the net height. This will be the answer. Write it down. Water rises in a capillary tube to height 2 centimeters in another capillary tube whose radius is 1/3 of it. How much water will rise? Okay, see, if we want to find out the level of mercury which has risen, see, just remember, height is inversely proportional to radius of tube. So height into radius is constant. So basically you will have H1 R1 is equal to H2 R. This is the formula that you'll be using. Simple. Don't go by the entire formula. Just use this. Height is 2, radius is R. The next height you do not know. And the other height is 1/3 of it. So just use this formula. See, H2 is directly 6 centimeters. Only this you had to write. Write it down. This is clear. H into R. Why are we using? If you notice, this is 2s cos theta by r rho g. 2 is constant, surface tension of the liquid is constant, angle is fixed, acceleration due to gravity is a constant, density is constant. Both are inversely proportional. H is inversely proportional to R, so H into R is constant. That's why we are using it. Write it down. You can leave now. On Monday, we'll have the class that I have discussed. All right, before your bio class. We'll complete this, some of the portion, because next week we have to complete all the syllabus. So we'll start directly with hydrodynamics. All right. So on Monday, we'll discuss. If you have any doubts, you can let me know. These three topics we'll complete. Okay. Thank you so much, class.